Hello everyone, I am Shuvam Swapnil and today's topic of presentation is CRUD and SQLite database using Liquid Galaxy Flutter apps. Okay, first of all, let's think from the point of view of a YouTube content creator. So first you make some video, upload it, give it some name, some description, and again you feel like no, I need to change the description a bit. Then you go to your YouTube studio, you do a bit of tweaking to your text written here, be more creative, and then update it. But there again you feel like after some time you feel like your video is outdated, it's no longer of use, so it is safe or there is no use of this video, so I can just delete this. Okay, from this very simple example I have explained something that forms the base of storing data in every software, that is CRUD: create, read, update and delete. So CRUD is the building block of data storing and updating and even deleting when we are working with our softwares. We have a lot of works that are related to CRUD. Let's take for example some kind of messaging apps. We need to create our message, store it, and even on our will we can delete it for ourselves, even we can delete the message for everyone. There is an option to work on that too. And talking about some kind of API management system, so we fetch the list, we uh, assign every single individual to the list view. So what is all this? This is storage. And every app you pick up your phone, you see that every, even there is a small thing like liking and disliking, that also is CRUD. So if we want to save some text, some posts, social media posts that we like, some videos we want to watch later, some images, some KMLs and whatnot. But nowadays the online and cloud storage is on trend. That forms a good base, but it is expensive and it is limited. So it is better to stick with the basics. So what is the basic? Offline storage. How to do offline storage? The solution is SQLite. So what is SQLite? SQLite is a lightweight, self-contained, serverless database management system that stores our data safely locally within our phone without the issue of any expenditure online or even data breaching. So it creates that safe environment inside your phone only in which you can store your data. It is an embedded database machine. That means there is no need of server or something. It integrates directly into your application and takes the storage of your mobile phone. So some of its characteristics or uh, things that define it is, first of all, it is serverless. There is no need of some server to be assigned to this, some cloud server or something like this. All the storage is taken up all by your local storage. And then there is no setup or administration that is required, something like API keys setup or like access to some kind of HTTP request, that is not required. It is absolutely hassle free process. And the best part is it works cross platform without any restriction of having it in Android and not in Mac, being native. No, that's not the issue. It works in each and every device we configure it on using our Flutter app. So there is a basic cycle that I have shown how it works. So this is the Flutter UI interface on your left. It it takes the data as input, stores it in the form of a table. Yes, this is one of the important things, that it stores the data in front of a table in every database that you can observe. So there is a particular format in which we enter and save our data. That is form of columns. We assign particular columns and means type, the data types, and after that we can assign all the variables accordingly. So what it does is the backend creates a table, stores it in the database of your mobile phone, and we can again access it in our UI using a list or grid view when the need arises, mostly when we initialize it. There is another thing that really forms the platform of how our database will work, that is schema. Schema is the structure that defines how data is organized in a database. So it is the, so to say, this is just like we are defining how we want our data to be, what is going to be our data type, what is going to be our entry, what is going to be our variable name, what is going to be our uh, overall structure or the skeleton of our table that we are requiring. This specifies all the tables, columns, data types, relationships, and even constraints. So these form the components of a schema. This namely, like we have already talked about tables, columns. Talking about the indices, this is what separates the data. This is the unique value of a data that we are assigning. So mostly this order is chronological, in the order we save the data, or it automatically increases, just like how we work in normal Excel sheets or something. And there are two unique things that separate, or that uh, makes it outclass from other database management techniques. So here there is a constraint. So what is constraint? We are, as the name suggests, it is constraining us to something. Like for example, it is if we write not null in schema of some variable. So if we do not provide an entry while entering or adding the element to database, we do not provide an entry, it returns an error. So the user is constrained that this entry needs to be filled, and there is something called primary. A primary is always assigned, like most of the cases it is assigned to the index, because it segregates how we are going to access the individual data with its unique identification number. And another thing is views, finally, which works for virtual tables. Let's take a quick look at an example. So I have, this is the database format of a schema, how we write. I have taken a simple example of students. So the table's name is students.db. The .db is the format in which we are going to save our database. So we have created this table named student, in which we need three entries. The first one is the ID, which works with this primary key auto increment. This is the constant, as I have talked before. This actually segregates what part of what it means, which serial number of data we want to access. It makes a lot easier to work with individual data and not as searching the whole part of it. Then the name of the student and the age. Here we have also assigned the data types, namely text and integer. So now it's our time to go to the code. So first of all, you have to import the following dependencies, and feel free to clone this GitHub repo, or you can create it yourself. So we are going to divide it in in two parts. In the first part, I am just going to work on this example only, because it provides a simple interface on how we are working with lists and tables in our this tutorial. So before actually going to the coding part, let me explain how I have created the architecture of this. So it is completely optional for us to follow the architecture, but following the architecture is always a good software development practice that we need to follow. So on the topmost layer is the UI layer, or the list in which we are going to show. Sometimes, for example, in Kotlin we use something called recycler view. Here we are using something called list view. So it like it uh, fetches all the individual elements and all the data types, all the parameters that are assigned to this then uh, talks on this then fetches all data individual in the form of widgets so that we can access to it. Inside this are three other layers. The first layer is the domain layer or the service layer. This is completely optional, but it is always a better option when we are going to top down approach. We are going to access a single element from a large database. Then again, inside that we have our repository and our data source or the database, in which we are providing the schema and initializing with the database or accessing the actual backend which is stored in the internal storage of our mobile phone. Let me scroll back to Android Studio. So I will start with as you can see here, as I explained here, the DB helper here is the data source, the table repo is the repository, table service is the domain layer, and again we have our widget in which we are showing our data. So first up, our task is to initialize the database or the table and its schema. So let me uncomment this. We are accessing this get application documents directory, which is under this package named path provider, because we have to also access which part of our internal storage we are going to store our database. So we call that, we created the file named studentsdb. So, and our on create function, you can see here this particular string is equal to what I have written here. It is exactly the same. It works the same way everywhere. So I assigned the schema to our database and executed it. Now it's our turn to go to the repo. Repo has the work to it forms the interface, it forms the top layer of our database, which helps to access all the functions. So here I have the direct access to the file, but here are all the methods that we need to work with our CRUD. So first of all, we will initialize the database. Then these five functions are the best example to show how CRUD works. So this is insert data or C, create, read data and read data by ID are R or read, update data U, delete data, that is D. So why there are two parts, namely read data and read data by ID. So when read data is required, when we show it in our UI, we need the whole table to be mapped to our UI. So we are reading the data as a whole, and a separate function named read data by ID so that we can access it while editing it. So there is this initDB. Then we have the insert function, the query function, which are the part of the SQLite database. Then the update function, and finally the raw delete function. So the table also calls the similar data, but here what it does is it connects us to the class or the class that we have created for each individual element. So there is no direct way to fetch all the available, as we can all we have entered here is a bunch of string, a long string. So we have no direct access to the data. So it needs to be mapped to all the elements so we can fetch it individually. So I have created the objects. This is the student object, which has the same parameters, name, age and ID, and I have mapped this so that we can work it out in as a method in between saving this and fetching this. uh, the service just assigns all the values of the table to each class, like it converts the the data in the table formed as a long string to a class, so that we will finally come to our UI. Here in our UI, the first thing that we will do here is uncomment this part. This function is I'll uncomment this also. This get list function ensures that all our elements, all our objects are loaded smoothly as a list, so that we can access the UI using it. So here is our here I have used the list style, the list view, in which I will be showing all the elements as a list. Before that, let me uncomment this also, so that we can run the app. Okay, so the app is running currently. Okay, our app has finally run, so I can show what all is happening here. Now that our list is empty, it shows add elements by clicking the plus button here, which I have accessed by using our Elvis operator, as the students list is empty. So uh, every time it gets initialized, whatever is stored in the database gets fetched using this list. Now our first job is to create an element. This is the dialog box that I will open in order to create our first element, and then uncomment this also. Let's give it a hot restart. So okay, now the dialog box will show up here. I will insert the person's name, age 19. I have added it, as you can see. Then it again refreshes this. As soon as I add my element, it runs the get list and it instantly gets added. But wait, I have added it, but there are two more buttons that just look functionless. So what are we going to do with it? Okay, this is my edit button, and this is my delete button. That's what we are going to discuss next. Next is my edit element function. I will explain this part. First of all, let me explain the add part. In add, I have opened a alert dialog box, just like this, which consists of two text controllers, name and age for both the values that are provided. The ID will be generated automatically out of the result, because you can remember that I have provided that primary key and auto increment and all. So this calling the function from the service, this insert element function, can directly assigns the ID to our mapped class, the mapped object of our class, so which we can work with correctly. The add function, what it does is, it I have created an empty student variable, which we can use as a temporary medium. I will use this as a medium to assign all the values to this, then add it as a student class to the list, and then again clear that thing up, and also additionally I will navigate it. So the same thing happens here when I cancel it. And next, when I implement my edit button, let me uncomment this. Okay, so again a hot restart. The edit element, then edit element again takes us to the next function, namely read element. The read elements function has already been implemented in the get list function, which we can see here. And then we have the read element by id. So I talked about that before, that why separate functions are needed for reading the elements all at once and reading the elements individually. So because this works when we edit the whole data set. So data, like I will now click on the edit button. Now another dialog shows up which will allow me to edit this. I will click on update. It does this pretty much same job here, just like the add element. What it does is just takes the in the first case we fetched id as a result, but here we are using id as a constructor to access that particular element, or that particular index in our table or the database, which we will then tweak with using our text controller. Here I am using two separate text controllers, not to be confused. And the final function is the delete function. Comment this again, a hot restart. Okay, so now I have this dialog box here. Before going to this, let me explain the delete function. Here we just simply went, like here we simply inserted it, and there is this query function that just called the whole table and showed it as a list so that we can fetch it. And again, read data by id, the same query function, just have given the additional parameter of id so that I can fetch that particular element. Very similar drill for update, but in delete I am again showing it as a schema, because we will go back from where we came. Again, we are working on the string form, not as an individual element. I have to write this delete from table. Table name will be provided, that is students in my case, and this where id equals to id. Again, this is the parameter that we are providing. There are multiple parameters to this. It is a bit complex here, like where and where args, but here it makes a bit simpler in the case of reading and updating. But here it makes a bit simple, like just write us put the caps lock on, right, delete this from this, and it's all done. Now I will again give it a hot restart. I had given, but just to make sure. And now I press on delete button. Delete, and as I switch it's done and dusted. So this is how I worked with the table using this single line string simple functions provided by SQLite without connecting to any other kind of backend. I am also going to show you something similar but just a bit different, that is creating our own image gallery. So you will be surprised to know that this is also kind of database that we are working with, but here the schema is a bit different. Here I have same thing, id and name I have assigned it, but something called base 64 string is there. What actually is base 64 string? Why are we not taking image as an input? So this is one of the I won't say flaws. This is one of the complications of database, that it does not take any form of output. It needs to be something, some primary data type like integer, string, integer, text, and so on and so forth. So we need to convert our image to something called base 64 encoding. Not to go into too much detail of that, but I will just say that it pixelates each image, and breaks it in some binary code which can be accessed using this string. And every image, mostly all the images, have this unique base 64 string code, which can be encoded and decoded using this inbuilt Dart package called Dart convert. So we need not worry about that. It will be done by itself. Again, so for simplicity, I have went to the next tab bar only. We'll follow the same drill before. I have initialized my gallery DB helper, which which I have differentiated it from this, because the schema I am following it to is different, as shown here. This is going to be my schema. I executed it. Again, another repo to access the database from backend, the service to connect it to its class or the object that I have defined. This is again just for a demo, for the purpose of demo. Both of them are very similar. I have to map, like, take all the parameters as input and map them, so that I can work with the database simultaneously while working with my user interface. And finally, we are going to our UI. Okay, again, this get list, I have to uncomment it. It does the very much similar job that I explained in the previous one. So not too much to explain this. And same for the add. Okay, wait. I have this dialog box which looks a bit odd to me. I have added this. Okay. It looks a bit different. So I have told to you, right? We can't take image as an input. So what to do with this? So we have our image that we will upload. We can take it as a picture. Right now the camera won't work because it is a virtual device. So I will stick to image with my gallery. I will upload this mango leaf, and it doesn't it this is the okay, the this thing is bit different from how we usually upload image. Here there is a small thing that I have changed here, is when we are working with dialog box, we are not using the set state function. I have commented this part because this might be something unique for this. Set dialog state will be used to update the UI inside the dialog. This is bit different from set state function that we use in our usual widgets, because this is something that is being derived from our usual widget. This is a part of our gallery view. So I will I will use the image picker function. I will take the input. I will upload the image, which takes the input as a file path. File path is a file variable that I have defined here. It does not take the image input directly. It takes the file path variable, and then to add this as an element of our database, right? Mango leaf. I will click on add. So how does this thing work there? This is due to base 64 encode. Base 64 encode saved it as a string, and again when it was our time to show the image in our list, what I did is, here it is a bit different. You can clearly observe the difference. Here in our case, table, I had created a list view, but here it is our grid view, so that I can flawlessly show the snapshot of our image in uh, a small space. You can discover it yourself. The gesture detector, this is so to get it into the full screen. So this is a bit different because I have stored it from the string, but again I have to fetch for each element or each photo of this list that is there. I have to again base 64 decode it in order to show that here. Now that I have uncommented the full screen too, I will again hit on hot restart gallery. Okay, now it opens the full screen view. Full screen view is a bit here I have modified it compared to the normal text database that we worked on before. So just to show that even if I change my widget, the context, the like the deleting or editing things, here we did not edit there, so I have not included actually the edit functions where we can just simply insert, read and delete the element. So as I come to the full screen view of this image, it shows the name up here in the app bar. Here are there is my back button, and here is the delete button. There is this genuine concern that when I change my context or change my widget, so it must be hard for us. So there is a lot of things involved. But here in database, it is not so difficult because I we are working on string, right? At the end of the day, this is what all matters. I can simply go to the full screen view again, call our service, which at the end of the day calls the string, and even if it is a different widget, the photo ID and all have been brought here by using using it as a parameter. So we have still access to the ID, which I can just simply click on this delete button and it gets deleted as I change my activity. Okay, just let me hit the hot restart. Okay, now the gallery is empty. We can see that we have successfully implemented our gallery also. Before concluding this, I would say that there are some scope of improvements in this code too, because I am working on our primitive individualistic presentations. So we are sticking to this code, which is, but there is a very less code reusability that I could not actually show in this part. We could use the functionalities of object oriented programming, like inheritance, to create a base DB helper and then extend the both student DB helper and gallery DB helper to have their own abstract classes and their functions, which can be implemented with this. Same applies to the repository and the service. It really simplifies our task, but as we are not working too much right now on multiple databases, we do not want to mess up this, so we can stick to this. But while working on real project, you should really consider the reusability of code, as object oriented programming is one of the core concepts of app development. So with this, I would like to conclude my presentation. Thank you very much.
Infinite power, infinite